because you most probably don't know me. I work at Powell. We create high-performance .NET software for energy producers and distributors. For example, we are balancing the energy, optimizing the production, forecasting, stuff like that. And in my free time, I contribute a lot to open source. I'm one of the core contributors to benchmark.net. I also contribute to core CLR and Corefix Lab. So in general, I really like the performance, and I really try to focus on the recent changes, and some of them are even my own. So today, I would like to give you an overview of what has changed recently, about all of the new language features.
And then you will use this one for convenient now?
It's okay?
Yeah. You should.
Okay, or maybe I should speak louder?
No. Use microphone.
Okay, did you propose?
Last roll, couple.
Yes, like this.
Okay, is it better now?
Whoa. Yeah. Much better.
So, today I would like to give you an overview. First of all, recent latest C#7 features in terms of performance, and recent new things that appeared in .NET Core. But later on, I will tell you why and how you can use them today in your existing .NET applications without .NET Core. After that, there will be, of course, some time for questions. So, let's start with tuples. So far, if you wanted to return few results from your method, you had to either create a new type, return few out parameters, or use old tuple and use the crazy item 1, item 2, item 3 name. So with C#7, we got new tuple. It has very powerful syntax support. So you just define the list of what you would like to return and just return it. And why do I speak about that in a presentation about performance? Because it's a value type. And in general, all of the things that I will talk today will be somehow connected to value types. So I will tell right now why it's so important. So first of all, value types. We got value types and reference types. And each instance of a reference type contains two extra fields. First is a pointer to a method table, and second one is a bit mask that is used internally by CLR to, for example, store the information about the log, the finalization, the garbage collection generation, which the object belongs. So if you have a value type, it has no overhead. Object, they have overhead. So when processor is reading memory, it's smart and it tries to predict what you want next. So if you go to memory and you first of all check in the cache. And if something is missing in the cache, then it goes to the main memory and reads whole line of the cache, usually 64 bytes. So when you read the first element of the array, it will read first, second, third, and fourth. So your next access to the array will be already present in the cache. So this is why value types have better data locality. And very important thing, they are not managed by garbage collector as long as you don't box them. So as you can create as many of them as you want, and you don't put any pressure on the garbage collector. Which is, as you know, .NET garbage collector is very good, but no garbage collector is better than any garbage collector. And the last thing, it has deterministic deallocation. So if it's a variable, local variable, then when the method ends, it's simply deallocated with a single instruction, stack unwinding. But, yeah, just a minor thing. If you would like to test it, you need to have a Visual Studio 2017. It's for free right now, in the release candidate mode, but you need to add an extra reference to system value tuple. And the error that you will get, the compilation one, won't tell you that. It will tell something different, but I really encourage you to try. But my question to you is, what are the disadvantages of value types?
readability.
We need the extra comparability.
Yes,
Yeah.
also, but in terms of performance,
More memory on the stack.
also, but most of all, they are expensive to copy. Because with object types, we simply send the reference or the copy of the reference. With value types, we always pass the whole copy. So if you have a huge type like 10 fields, then it's more expensive to send it to the method. And all of the other advantages might not be so cool, and it's better to use object at some time. But you also don't know when it happens. Let's consider this simple example. We got a read-only field, which is referencing to a structure. And we call a method on that field. So what C# compiler emits in Ryujit code is something like that. Create a copy of the structure to have pure immutability, and then call the method. So you thought you are calling a method, but you copied the whole structure and called the method then. So it's not very convenient, and it's bad in terms of performance. This is why a lot of people avoid structures. But C#7 addresses this problem. We can now return a reference from a method. We can also, as we could before, we can pass parameters via reference to the method. We can create a local reference, and we can create reference to a parameter, as we could before, field, and other local variable, which was not possible before. And of course, we work with that, and we have to return the reference. So it's great in terms of performance, but as you can see, we got 1, 2, 3, 4, 5, 6, 7 usage of reference keyword. So this is not for your daily code. It's rather when you find out that you have a problem and copying structures is expensive for you. This is when you reach for this kind of code. And why would you do that? Let's do some benchmarking. So we have a structure, it's kind of big, 5 integers, and you would like to initialize an array of structures. So previously you would have to create a copy, do the initialization, and once again copy the value to the destination storage. But with references, we simply create a reference to the storage and operate on the reference. So the difference is quite huge. It's like 4.5 times faster. So it's worth to try. But as you can see, on the right, you got a legend. And I have compared 3 different JIT compilers. The legacy ones, 32, 64, and the new Ryujit. So it turns out that the feature for having references to anything in .NET was already present in CLR for many years. But the C# team decided to not implement it so far because it wasn't needed. But recently, .NET is trying to go as performance as possible. They are pushing, and this is why they needed that. So a lot of things is changing. And also previously you could go unsafe, so you could actually work with structures by references. But as you can see, the code got a little bit more complicated. We need the unsafe keyword, we need to pin something, and then we need an ampersand and some other stars. So it's rather not the way to convince the clean coders in your team to code. But previously we've been using Unsafe in order to get very good performance. But I have compared how does it cost to do that by value, reference all way, 3 ways of doing the Unsafe. The code that you have seen was the fastest way. But in general, today we can get a code that is faster in safe mode than we could previously with Unsafe. So this is really cool. And when you are doing some unsafe calls, you need to know that you need a full trust to run your code. So for example, Azure for a long time did not allow that in their policy for the web jobs. So for example, 2 years ago I created a link optimization library on top of Unsafe and getting private members, and then I tried to execute in the cloud, and I realized that I was getting some exception that was telling me, look, you are not safe. It's not possible. And this is why a lot of high-performance code, like the Stack Overflow JSON serializer called GIL, is not using Unsafe. And the difference here, this 10 nanoseconds, is because we didn't need to pin the object in the memory. And by the way, the new references are safe. So, what does it mean? When garbage collector is doing its job, it might decide to compact the memory because the memory is fragmented. And if you want to go to unsafe word, you go to the native word. And you create new pointers, and garbage collector has no idea what it is. So it cannot update this pointer. This is why you need to pin the objects in memory if you want to go unsafe. So if you are using managed references, they are being recognized by garbage collector, and there is no problem with them. So you don't need to pin. The next thing is that we got few ways to allocate memory: managed and native. And native, we got stack-alloc, which is quite limited, but actually the fastest way. It's almost 2 times faster to allocate 100 bytes with stack-alloc than with the new operator. But it has some disadvantages. It's of course very fast to allocate, deterministic to deallocate, but it's unsafe to work with, not very common across the APIs, and kind of limited. On the other hand, the managed memory, we can allocate it very fast. The deallocation is very expensive because it's non-deterministic, and DC is working in a way that when it starts to work in the second and third phase, it suspends all of other threads in the application. So, how do you think, what could be easier to achieve? The implementation of new real-time garbage collector, or making the unsafe memory more easy to use? Any guesses? Yeah, most probably as developers you would like to get the task for implementing the real-time garbage collector, but the second one is the way to go for now. So, span is a simple type that allows us to work with any type of memory. It does all of the pointer arithmetic for us, and we can simply work with unmanaged memory, managed memory, or strings. And everything is type and memory safe, so we don't need to worry about that. And it has almost no overhead because it's a very simple structure, and it's supposed to be as fast as arrays. And when I told that you can use any kind of memory, so for example you get pointer from the stack-alloc, you can create span out of it. The next version of C#, most probably C#, you will be able to directly assign the result of stack-alloc to span, and without going unsafe. The same is for Marshall. So you got managed type and memory safe type here. And of course this is also possible for the arrays. And the advantage is that so far if you wanted to be to support both ways, managed and unmanaged, you had to provide a method that would accept pointer and the length and the array. But now you will be able to remove them and simply add a single method that accepts spans. So for the people that don't have time to support unmanaged memory, they will just change array to span, and all of a sudden everybody else that is using native memory or not will be able to use their public APIs. And how do you work with span? It's very simple. It has the indexer, struct enumerator, length, and few methods for copying the memory, seeking for the first matching bytes, and doing some comparison. But in general, span will have some limitations because it's hard to manage the ownership of the memory. So for example, span will be the first public stack-only type. So it will mean that you will not be able to store it in a field, but you will be able to use it in your method and send it to another method. But this topic has been not solved in 100% yet, and this is why spans are not in the production today. But the good thing is that they have been already merged to master for core CLR, the next version of core CLR. And speaking of that, we will have two spans. One for the new runtimes, and this will be a pointer to the beginning of our span, to the beginning of our method, and simply the length. And this pointer will be recognized by the garbage collector, so everything will work out of the box. But for the old runtimes, spans also will have the support. But the internal implementation will be a little bit different. You will have pointer to the parent object. For example, we have created a span from a string, and we only wanted some part of the memory. So this is the beginning of the source string, and this is the offset that we wanted to substring. And due to that fact, you will be able to add spans to your, for example, library, and nobody will have to change the target.NET Framework version. Like, for example, if you want to use async local, you have to switch to .NET 4.6. With spans, it's not going to happen. The purpose is that they should be very simple and easy for the people to use. So I believe that in the next few years, it will be one of the most commonly used types next to array, strings, and integers. And speaking of subslices, such a simple operation like create a slice out of the string is not anymore a copy of memory. Because if you want to substring, you allocate a new string, and then the content is being copied. Here is just a simple pointer arithmetic. So you just add an offset. And every method inside span is implemented and based on pointer arithmetic. But the good point is that the end users don't need to worry about that, because we just have a nice managed API to work with it, and it can be just fine. You don't need to understand how it works if you want to use it, but it's of course great if you do. And to convince you, how much does it cost to substring a string? How much does it cost to subslice it? It's much more cheaper. And there is a lot of places in .NET when we got some big string and we make some smaller strings out of it. So for example, formatting, encoding, parsing HTTP request, compression, decompression, JSON. Imagine that you have a huge JSON and it's a simple object with only one field that is a string. So today you would create a new big string and copy this whole field inside. With spans, the future JSON deserializers will just do the pointer arithmetic. And this project is very open. It's not in the release to manufacture part yet, but if you would like to find a project where you could start your open source journey, this is the project that I advise you to try at least. Because all of these APIs are needed to be implemented. And me as a person that had no public recognition 1 year ago, I just started contributing to Joel Duffy project spans, and it ended up in a way that first of all I contributed to his project, then to CoreFix Lab, and then I ended up emitting IL in the CLR virtual machine writing C++ code. So really a great thing to do, and really a thing that you will be remembered. You'll be able to say, look, like, you know the new array? I have implemented half of it. Like, oh, nice. And before I speak about the next problem we have with the memory, I would like to show you how it occurs for the end user. So we have a real-time game here, and it's working smoothly, and now look, everything has just disappeared. So do you have any idea what have happened on the backend side of this game?
GC.
Yes, GC. Full GC. We got Gen 0, Gen 1, and Gen 2. And we really want to avoid this garbage collection because most of the time this is the biggest part and it takes not milliseconds but even seconds, as we could see in the example. And the problem is that large object heap, which is the heap where all of the big objects are stored, is bounded with the Gen 2. So anytime we create a large object like an array or a string, it's born as a Gen 2 object. So if you have a lot of allocations in log, the GC will try to reclaim memory, but not only here, but also here. And this is why we should avoid allocation of the big objects. The good thing is that Microsoft, when they were developing Kestrel, they have found great solution for that, which is of course simple pattern object pool, but they have shared their implementation, which is extremely tuned. So we got ArrayPool. It's available in the system buffers package. It's a simple tool that enables you to rent and return the arrays, managed arrays, and they have max size. Each pool has a max size. It will be important, I will talk about soon. So how to use the pool? First of all, we need an instance of the pool. So it has the shared property, and it's thread safe property that returns you the default pool. But it has the default size limit. You might create a new pool. The ArrayPool has also a create method, or you might derive a custom class from ArrayPool and implement your own strategy for renting and releasing arrays. And once we have it, we rent. We say what's the minimum size of the array we would like to get. And a very important thing is that the array that we get will be most probably bigger. So for example, if you are reading a web request and you get the size of the web request and you want to, and you rent the buffer and you want to write a for loop, then you don't rely on the array length because it will be bigger than what you have asked for. So just keep this in mind. And then we simply use this array and at the end we return it to the buffer. And in that way we can reduce the large object heaps allocations in a very big way. And just another benchmark. On the left, the shared pool, the second column, native pool, it's another pool, but it's based on spans and it's not so tuned yet, so I omitted this part. New operator, and the pool that is aware of the size that will be most probably allocated, and stack alloc. So for 10 kilobytes, the difference is, okay, it's huge, it's big. But for 1 megabyte, it's even hard to compare. I'm not sure if the people that sit in the end of the room can see that I have some results here. And as I told you before, if we allocate large objects, we get a lot of Gen 2 collections. So this is what you want to avoid. But there is one problem with the default pool. As you can see, for 10 megabytes, it's almost as slow as new. I told you before that it has the default max size. So if you ask for something bigger, it will simply create a new array and return it to you. But the good point is that the system buffers package already supports ETW events. So if you are profiling your application, you will see an event that will tell you about that. Look, you have asked for something more. And it's very important to not create too many pools, because what we wanted to have is a small large object heap. But if every part of your application has its own pool, then we end up once again with a lot of large objects. So it's good to use the shared one because ASP.NET is using this. A lot of third-party libraries today are using that. But for some of the sizes, it might be not enough. So it's good to know your domain and your application, and so you can foresee what you will need. The next problem that was recently addressed was following example. We have a very small method, which is asynchronous, but most of the time it could run synchronously. But here the cost is quite big for the task allocation. Task is a reference type, and it has at least 7 fields. So imagine that you are doing some socket operations, you know the result, and anytime you want to return a byte, you allocate an object. So this is of course not good. So, and if you want to consume this method, you are awaiting this method and using the result, of course. But the problem with await is that it emits the asynchronous state machine, and this is quite complicated code, and the result is that this method cannot be inlined. And as I told you before, this sample is small. The value tasks are for this problem, and here the idea is following. We don't want to replace the task. We have a discriminated union. We have result or another task, the real task. So when you have the result now, you return a value task that simply wraps this result. Otherwise, you return value task that wraps the old task. Okay, and how is it implemented? Like here, we got value task. If I can run synchronously, I return the synchronous result. Otherwise, I return it the old way. But the point is that this can be inline. So you might get a huge gain. And the most important thing, how to consume that, is that you call this method without await, and you check if it was completed, and then you can start using the result. And this can be all inline. So for small methods, it can be really huge gain. Otherwise, you go the old way, so you just await the inner task, and you have the old performance. So where we could use value tasks? In sockets, file stream, ADO.NET data readers, anywhere where you have a such limited but quite popular scenario. What we get is less heap allocations at method inliner. So when Ben Adams introduced value tasks to the recent ASP.NET hosting server called Kestrel, he improved the performance of the benchmark plain text by 2.5%. And this is the benchmark where all of the other companies are trying to compete in. So if you have seen the recent news about the .NET Core 1.1 release, there was a nice chart with 10 fastest web platforms, and it's always the chart from the plain text. So this is where everybody is trying to compete. So 2.5% there is a very big increase. And just to tell you how much does it cost to create a task versus how much does it cost to create a value task. So the difference is huge. And now, let's take a look at typical web request. So, first of all, the data is being read into a socket, into the buffer. The buffer is most of the time a new array. We allocate a new array. Then we parse the HTTP. So we allocate new strings because we want to, for example, check what are the headers. Is it get, with, whatever. Then there is a decompression. So from bytes, we get another bytes. New allocation. And then we decode we got routing, and at some point we do the JSON decoding. So again, we had a huge string, and now we are decompressing, deserializing that. Another allocation. And in the other way, it works in a similar way. A lot of allocations. So, David Fowler decided to use all of the tools that I have just explained. Buffers, tasks, value tasks, and spans. Mark Gravel called it high performance, quite a long name. I call it zero copy buffer streams. So how does it work? We have a pipeline, and instead of just reading, you just await, and the other part is just pushing new events. But the point is that before it does so, it asks the other side for the buffer. And if we take a look at the whole flow, so left side, ask for a memory buffer, then the other side returns a pooled memory, so no new allocation, and starts waiting for the data, then the other side starts writing to this pooled buffer, then the other side starts reading, and now is doing all of the things that previously allocated strings with spans, so no allocations. And at the end, when this side has finished handling, int returns the pooled memory to the pool. So here it's important that this side previously had no idea when to return this memory. So if you take a look at it, it's quite a simple idea. We just change the way and the thing who is responsible for what. And what we get is a zero copy string. So you can actually handle a web request without any new allocations. So imagine that you have a web server and it's quite busy with handling new requests and the memory is hanging out at 200 megabytes and not moving out. So today, this project called pipelines or channels is still work in progress. So it's very rapid development. A lot of things are changing. But the good point is, I unofficially believe that David is trying to put it in order to get it for the next release of Signal R. So this is why the spans were merged to master, even if a few months ago they told me that it's not going to happen within a year. So most probably we will get them in next year, and new Signal R will be based on that. So as the end users, we will be just able to update the package reference to Signal R and get a very, very nice performance. And this project is also another project that is very open for the contributions, and there is even more things to implement. Yeah, as I told you before, I believe that this will be a really huge thing, so we can actually, instead of reading about the history of open source, you can make your own. So such thing didn't happen in the world of .NET for a long time, at least in my opinion. The last API that I wanted to only shortly mention is the new Unsafe class. So in general, we got a common intermediate language and C#, and one compiles to another. But what C# offers is only a subset of the things that IL code offers. So if you wanted to do some IL hacks, you would have to write in the IL. So for example, in C# it's impossible to get size of any type. You can get size of primitive type, but not of an object, for example. And you cannot also emit the copy blocking structure or init blocking structure, or cast whatever you want to whatever you want. And if you are sure that you know what you are doing, and previously you've been doing that by writing IL code, then here we got an API that simply has this implementation internally, and you can just use it in your C# code. So maybe your compilation process might get simpler, and maybe you might avoid a few problems because all of these methods are very extensively covered with unit and integration tests. So, but this is only for the people that used to do some IL hacks before. And as I told you before, I wanted to say how to use these tools today. So we got a new thing called .NET Standard. So previously, if you were an author of a library, and you wanted to support Monoc, Xamarin, and .NET Framework 4.5, you would have to target 3 of them. And you would have 3 different compilation settings. But Microsoft decided to change that, and they have decided to introduce a standard. So frameworks implement a standard, which is just a set of APIs. And if you are a library author, you target a standard, not the framework. So what you get is that if there is any new platform in the .NET and they simply implement the standard, your code will be able to work there anytime. And recently, when Xamarin joined Microsoft, it's much more. There will be much more code that will benefit from that. So, and .NET Standard 1.0 is a .NET framework 4.5. So you can use buffers today in your existing .NET Framework desktop application. But the thing that you might need is an update of the NuGet package manager, because it needs to understand the .NET Standard. And other extra information, if you don't want to wait for a new release, each of this project, they have their own continuous integration feeds, which are publishing NuGet packages after each build, successful build. So if you don't want to wait for a new version of buffers, you just switch the nugget.org to the core fx CI feed, and you get the change from yesterday up and running in your code. So before I ask about the questions, I would like just to summarize this a little bit. So I would say that recently a lot of things have changed. If you take a look at these ideas, there are not any big innovations in terms of other platforms, because we got an implementation of the pull buffer, of the pull pattern. We got spans, which are available in, for example, Rust. We got ValueTask, which are also available in other languages. But it clearly shows that Microsoft is taking this really seriously. So I believe that we are heading into the right direction, and maybe one day we'll be able to tell that today .NET is a high-performance framework. So, and now it's the time for the questions.
Great. It was first talk in English on our meetups, and I hope everybody understood. So your questions? I will help you to translate if you need. No? No questions. Great.
There was one thing that confused me a bit. You talked about string slices, but we can end up in a situation when we received quite a big string, like 2 megabytes or something, then broke it down to small parts for JSON values or something. Then one of those slices was referenced by something, right? And then it was retained somewhere in long-run background operation. So that big string will still live to the point.
Yes. There is other type called memory and all memory, and it's almost a span, but it's responsible for keeping it alive. And this is not so intuitive and easy as spans. There's a different one for the native and managed memory. So the output implementation, all of the methods will use span, but the thing where it will be keeping it alive will be a type called memory, or something that implements I-owned memory interface. So, yeah, thanks for pointing this out, but I didn't talk about this in depth because it's very rapidly changing, and it seems like today there is really nobody that has the perfect solution. There is ongoing discussion, and the implementation is changing very rapidly.
Anybody else?
I have a question.
Great.
Just my question is about ArrayPool. Just as far as I understand, we have to return back memory which we allocate, yes?
Yes.
So it means that it's like the C language, we have to follow rules
Yes.
which usually used for this. So it means maybe you can do any recommendation how we can use it.
Yeah, it's a very good point. So we are making one step back to make performance improvement. Yes. So if you are using pools, you are responsible for that. My recommendation is to use it only in places when you can control the lifetime. So for example, a web server. You know that you have ended receiving, it's end. But in a desktop application, which lives for a long time, it's hard to tell how long is it going to live, when I should return the buffer to the pool. So then, if it's not a performance problem for you, I would use the old way. But this only in the places where you are sure about the lifetime. And always use the finally. So anyway, if we have an exception, we return it to the pool. One more question?
Not a question, but not a question, but maybe a comment. C# was, when it appeared many years ago, it was positioned as a simple language that you don't need to know anything about references and so on. The runtime will do anything for you. And now we see that there are references, there are some tools that you can forget to do something, and it will live for long, and you have problems. So, as it was already said before, isn't it one step forward and 10 steps backward?
It depends. If you are the end user, and you are, for example, using ASP.NET and Signal R, you get only the benefits. This is the implementation detail for you. But if you are a library author and you would like to improve your performance, then you learn these new things and apply. And then you need to be careful. But I know that it also, for me, for example, when we are doing a code review, I never tell people that this is 100% right or wrong. If somebody wants to add references, we will do a debate. If most of the team will say, we don't want to see it because only you know how it works, I will say, okay.
But potentially we have more and more possibilities to have problems.
Yes, but you are not forced to use them.
But we will have some junior programmers
Yes.
that heard about new features. Let's try a new feature here.
Yeah, that's why it's good to have the code reviews.
But it's a possibility.
Yes, but on the other hand, the junior developer could anyway break the code if it's not being observed. So yeah, I get your point, but you don't need to use it, but you might get the benefits as the end user if you, for example, use the cast route.
Then do we really need Core RT and .NET Native if everything is so performant?
Yeah, so the .NET Native is the compilation of the code from the intermediate code directly to the native code. So for example, this was introduced for Windows Phone, as far as I remember. And then the benefit was that once we have the native code, we can apply the optimizations from the C++ code. And it was, of course, beneficial, but kind of hard to make all of the things right. But these two things don't exclude, because, for example, Core RT will give you also a compilation to the native code and a lot of optimizations. But you can actually combine this both, like use the pools, but get the code JITed first and have no extra cost of the first code. So in general, the Core RT is another project. It has more than 1,000 stars on GitHub, and it's another CLR machine that it's trying to combine some of the existing optimization engines, like I don't want to give them wrong name, LLUV? Yeah. So the goal is like transpile the intermediate code to something that other optimizer can optimize, and let's check the results. What might be the benefits? What I see is that, for example, recently JIT code is adding a new features when something is missing. For example, recently Ben Adams merged a huge pull request to Kestrel, but it required a single change in JIT. And because now it's very important to have a performant platform, the JIT decided to do that. If .NET Framework was closed, they wouldn't even know about such a problem. And they are trying to approach from multiple directions. For example, recently garbage collector was a single CPP file, like, if I'm not wrong, at least 40,000 lines long, and it was auto-generated by another program. So what the ongoing work is that they are splitting it up to multiple classes, multiple files, and they most probably will allow to inject an implementation of garbage collector as an interface. So something like we can do in Java. So I would say that Microsoft is working on the performance from every possible side. So I hope that we will be able to use all of them. So the new shiny things, the new shiny compiler, and for example, a real-time garbage collector. But this is a far future. So maybe not so far, but let's hope so.
Thank you for a great answer.
Thanks for a
So,
very good question.
anybody? Then thank you a lot, Adam, for your session. We have enough time to speak with Adam and Igor, to see HoloLens again, if Igor don't mind, and to eat something on that table. So
Yeah, just a minor advertisement. If you like details like that, or even more hardcore, I would like to invite you to my talk at .next, where I will be talking about exceptional exceptions.
I also want to tell you that Adam today reminds you with his T-shirt about .next conference that will be on Friday in Hotel Radisson Slavianskaya on Kievskaya station. So welcome, and you can find there not only Adam's and Igor's talks, but a lot of other different hardcore talks, really interesting. I've heard several of them, really good. So I will turn on my contacts again, and now any questions, any talks, so thank you.
Я